Metals.
Metals. Okay, very nice. So let us look at the formation of cation. So we said metallic substances or metals lose electrons, and you know that they will lose electrons in their outermost shell, isn't it?
Mm-hmm.
So atoms lose electrons in their outermost shell in order to form what? Ions. So there are three different types of cations. One, we've got what we call a monovalent cation. Second, we've got what we call a divalent cation. And third, we have got what we call a trivalent cation. Are we there?
Mm-hmm.
We said there are how many types of cations?
3.
What are the three cations?
Monovalent, divalent, and trivalent cations.
Very nice. So now you need to understand to say that the word mono means one. The word mono means what?
1.
Yeah. And the word valent comes from the word valency.
Mm-hmm.
And you know that the cation is a positively charged ion, isn't it?
Mm-hmm.
So monovalent ions, these are ions that are formed when metals lose a single electron. What do we call ions that are formed when metals loses a single electron?
Monovalent ions.
Very nice. Monovalent ions. So if I ask you what are monovalent ions, you say these are ions formed when metals lose a single what? Electron. Are we there, madam?
Yes.
So these are ions formed when metals lose a single what? Electron. Are we there?
Mm-hmm.
These are ions formed when metals lose a single what? Electron. I want to ask you a question. Which group on the periodic table will be made up of elements that will lose a single electron?
Groups 1 to 3.
But will lose a single electron.
A single electron, no, that's group 1.
Group 1. So let's say we have an example. Let's say we have got an example. Let's start with a neutral atom for sodium, right?
Mm-hmm.
What's the nuclide of sodium? We know that we're going to have Na. What's here?
11.
11. Good, madam. What's there?
23.
23. What's the electronic configuration?
That's 2,8,1.
That's 2,8,1, isn't it? We know that this sodium is a metal, and we know that sodium is in group 1 because it has got one electron in the outermost shell, isn't it?
Mm-hmm.
It's in period what?
Period 3.
Why is it in period 3?
Because it's got 3 shells.
Very nice. Then what's the valency?
The valency is 1.
Very nice. Why? Because it needs to lose this single electron in order for it to be what? Stable, isn't it?
Mm-hmm.
And we say that electron that it needs to lose in order for it to become stable, it's its valency, isn't it?
Mm-hmm.
So now, in order to form, so if we check in this one, madam, if we check in this one, this is a neutral atom. I've got a question. What's the proton number? What's the neutron number? What's the electron number? We go through quickly.
Proton number is 11.
11,
Neutron number is 12.
Neutron number is 12,
Electron number is 11.
Electron number is 11. Why is electron number 11? Because this is a neutral atom, isn't it?
It's still neutral. It's still a neutral atom.
Very nice.
Mm-hmm.
I love what you're saying. And we said that in a neutral atom, the proton number is equivalent to the neutron number. The atomic number is just the same as the electron number. But in order for this sodium to form an ion, it uses how many electrons?
It loses 1 electron.
So if it loses 1 electron, what charge is it going to attract? Positive or negative?
A positive charge.
So it's going to attract a positive charge like that, isn't it? Then we say that the proton number will be equal to what it maintains, right?
It maintains, yes, remains
It's
unchanged. So it's
11.
11,
Very nice. What's the neutron number?
12,
Then what's the electron number?
10.
10, because we say that when an atom loses electrons, the number of electrons decreases while the proton number increases, isn't it?
Mm-hmm.
So now if I
It
ask you
stays
to
the
say,
same.
very nice. If I ask you to say, illustrate the formation of sodium ion like that, how are you going to illustrate the formation of sodium ion? It's easy. We're going to start with the element for sodium, sodium like that, sodium. Have you seen that? Is it losing an electron or gaining an electron?
It's losing an electron.
So if it's, we're going to say minus C. How many electrons is it losing?
1.
So we're going to say minus C, the electron that it's losing, then it's equal to, after it loses a single electron, which is this single electron, then now what is it going to, it's going to have what charge?
A plus charge, a positive charge.
Yeah, so this is now this is the ionization equation for what? So sodium, how sodium forms an ion. So this negative means that sodium has lost how many electrons?
It's lost 1 electron.
Very nice. Then therefore, we can write the electronic, how are we going to write the electronic configuration now for sodium plus? Now, it means that the proton number, it means the proton number is reduced by, so after it loses an electron, we'll go with 10, isn't it?
Mm-hmm.
So how is going to be the electronic configuration? It's going to be 2, comma what?
2,8.
It's going to be 2, comma 8, isn't it?
Mm-hmm.
Very nice. So it's going to be 2, comma 8. So this is the electronic configuration for sodium atom. We're there?
Yes.
So that's the electronic configuration for sodium ion. Then this is the electronic configuration for sodium atom, right? What type of an ion? What type of an ion is a sodium ion? What type of a cation ion is sodium ion?
It's a monovalent cation.
Very nice. Let us look at the formation of another monovalent cation. Then we go to a divalent. I think we did this. So today I'm going to introduce you to radicals after we're done. Is it okay?
Okay.
Yeah, so we can start radicals after we're done. So now let's move on. In order to form monovalent cations, we go to which group on the periodic table?
Sorry?
In order to form monovalent cations, we go to what group on the periodic table?
Group 1.
Why? Because group 1 have got the tendency of losing 1 electron, which is their valence, isn't it? So they can only lose a single electron. And because they are losing a single electron, they'll attract a positive charge, isn't it, Madam Masowe?
Yes.
So we can just pick another element from group 1. I'm sorry, I'm going to be quick a little bit. So let's say we have got lithium. Here we know that we've got 3. Here we've got what, 7, right?
Mm-hmm.
Quickly, what's the electronic configuration?
2,1.
So the electronic configuration is going to be 2, 1, isn't it? Protons, neutrons, electrons. Let's just do this for the last time. Protons, neutrons, electrons.
Protons 3. Neutrons 4. Electrons 3.
Okay, very nice. We're making progress.
Mm-hmm.
Then it's going to lose how many electrons in order to form? So it's we know that it's going to lose 1 electron, isn't it?
Yes.
If it loses 1 electron, what charge is it going to have?
Positive.
Positive.
Plus.
Okay, very nice. So plus, then what are we going to have? What will be the electronic configuration?
2.
It'll be just 2. What's the proton number? What's the neutron number? What's the electron number?
Proton number would be 3. Neutron number will be 4. Electron number will be 2.
Very nice. Hence, the electronic configuration is that. Let's show its formation. We'll start with the lithium symbol. Then we're going to put what, minus or plus?
Plus.
Hmm?
Which one?
Here, to show the equation, it's going to be
So it's
minus to show that it was losing
an electron.
Losing an electron. So it loses an electron. Then after it loses an electron, it's now going to have what charge?
Plus.
Plus. So that's how we show it. Are we there?
Mm-hmm.
Okay, so let us look at the formation of another monovalent ion, which is potassium. So I'll just use the number here. What's the number here? What's the number there? It's 19, right?
Mm-hmm.
Yeah, so the number there is 19. Let's just go quickly. I don't have a periodic table, so let's say the number there is 19, isn't it? So if the number here is 19, let's just use this one. Let's break it down. Let's be quick. What's going to be the electronic configuration? What's the electronic configuration, Madam Masu?
Configuration, that's 2,8, 8,1.
8,1, isn't it? Very nice. Then if I have potassium like that, it's going to lose how many electrons?
2,8, 8,
So it's going to be 2,8, what? 2,8, 8, isn't it? Then how do we show that the ion has been formed? Madam Masowe, are you still there? Madam Masowe. Madam Masowe.
Hi, Mr. Kiran. Sorry, I'm having some issues. I don't know what's going on with Airtel.
Oh, okay, I hear you. But you're okay now?
Yes, I think so.
Yeah, so we said in order for potassium to form its ion, we know that we'll start with the symbol, right? We'll just get the symbol. So just get the symbol. It will be potassium like that. It's losing how many electrons? 1, so just put minus the electron, isn't it?
Mm-hmm.
After it loses an electron, what charge is it going to attract?
Positive charge.
Yeah, so this is the equation to show the formation of potassium ion. So if I say write the symbol for potassium ion, you don't have to write the whole nucleide, like putting 19 there, putting what and the mass, you just say that. So that's potassium ion. If I say sodium ion, you don't have to write the whole nucleide. They say nucleide notation of sodium ion. But if they just say write the symbol of sodium ion, it's just like that.
Okay.
For lithium ion, just like that. Unless if they say nucleide, that, then you say put plus. But you don't have to go just that and the charge.
Okay.
Yeah. So let us look at the formation. Let us look at the formation. Let us go and look at the formation of divalent cations. So we said what are monovalent cations? We said these are cations that are formed when metals lose a single electron, isn't it? So these are ions formed when metals lose a single electron. Then what are divalent cations, madam? What do you think they are? The word di means two. So what are divalent ions? Divalent cations.
Divalent cations are cations that are formed when metals lose 2 electrons.
Very nice. As easy as that. So these are cations that are formed when metals lose 2 electrons. I've got the question. Which elements on the periodic table have a tendency of losing 2 electrons?
That's the group 2 elements.
Yeah, so we'll go in the group 2 elements. So an example that we're going to use magnesium. Are we fine?
Yes.
So we're going to use magnesium. So if we start with magnesium, we're going to start with the symbol for magnesium like this, isn't it? It's going to lose how many electrons?
2.
So what am I going to put? I'll put negative, then I'll put 2 electrons. You know why I'm putting 2 electrons?
Because 2 electrons are being lost.
Very nice. Then we put that. I'm going to have my symbol for magnesium. What's going to be my charge?
2 plus.
Very nice. 2 plus. So that's the formation. Are we fine? Yeah. So let's go back and we do. So what's going to be the electronic configuration? So we can start with the electronic configuration for just magnesium like that, isn't it? It's 12. On top there, it's what? 24. What's the electronic configuration for this one when it's neutral?
That's 2,8, 2.
2,8, 2, isn't it? After it loses a single electron, we know, it loses 2 electrons, it's going to be like that, right? But how is going to be this if we had to write it?
It's going to be 2,8.
It's going to be 2,8. Why is this that 2,8? Because our plus there shows that it lost how many electrons? 2 electrons in order to form that. So what type of what type of a cation is this one? What type of a cation is magnesium?
It's a divalent cation.
Very nice. It's a divalent cation. What there? So if I want you to show the illustration for the divalent cation for calcium. So I'm going to have calcium. Then what am I going to have?
Calcium. And the calcium.
So I'm going to have calcium. Then how is going to be my equation? Minus?
Calcium is minus 2e.
Minus 2 electrons. The reaction arrow. So we call that as the reaction arrow. Then what are we going to have there?
Calcium 2 plus.
Calcium 2 plus to show the ion, isn't it? And we know that calcium is 20 down, it's 40, right? What's the electronic configuration?
That's 2,8, 2.
Very nice. That's 2,8, 2. Then how about for our ion, our divalent ion there, 2 plus, right? Our electronic configuration will be equal to?
The electronic configuration is going to be 2,8,8.
2,8, 8. Very nice. Nothing difficult here, isn't it?
No.
Then I've got a question. In what are trivalent cations?
These are cations that are formed when elements lose 3 electrons.
What type of element?
So we can say metals, but I think I can prefer to say those elements of group 3.
Very
So
nice.
basically
Group 3
metals, yeah.
elements, good. They are also metals. So group 3 elements are metals. So 1 up to 3, those are metals. Are we fine?
Yes.
Yeah. So in group 3, we've got the metal called aluminum. We've got the metal called aluminum or aluminium, which is a or like that. Show me its formation. Minus
3e.
Minus 3 electrons.
The reaction arrow giving aluminum 3 plus.
Very nice. Giving aluminum 3 plus. You're very smart, madam. We're okay?
Yes, we're okay.
I'm sure you know how to do the nucleides, right?
Yes.
Okay, very nice. Because I don't want to bore you. You're okay, right?
Yes, I just need to remember the numbers of the
Okay, no
elements.
problem. So here we've got that. Here it should be 13. Then there we should have 27. What's the electronic configuration?
13 electronic configuration. That's 2,8,3.
2,8,3, isn't it? Good. It's going to lose how many electrons?
It's losing 3 electrons.
If it loses 3 electrons, what is going to be the charge?
3 plus.
3 plus. What is going to be our EC?
So the EC, the new one, that's 2,8.
That's 2,8. So the neutral atom is known as the parent atom. Is it okay?
Okay, yes.
So the neutral atom will call it as the parent atom. Then the ion formed, we're going to call it as the daughter atom or just the ion. Are we fine?
Okay.
So if I say write the electronic configuration of the parent atom, that's that one. Then write the electronic configuration of the ion, that's that. We are fine, isn't it? All right. Let's move on, madam. Then what are we moving on to? Let's move on. So there are only three different types of cations. I told you to say we've got monovalent cations, divalent cations, and we've got trivalent cations. Let's move on to anions. What are anions?
Anions are negatively charged ions that are formed by gaining electrons.
Very nice. Then what type of substances gain electrons?
Nonmetals.
Nonmetals. Why do nonmetals gain electrons? Because nonmetals are electronegative. Nonmetals are what?
Electronegative.
Yeah, so electronegativity is the ability of an atom to gain electrons. What is electronegativity?
The ability of anions to gain electrons.
Very nice. So the ability of an atom to gain electrons is what we call electronegativity. Then what's electropositivity?
Electropositivity is the ability of cations to lose electrons.
Don't say cations, you say elements.
Oh, elements, okay.
Very nice. Then what type of elements are electropositive?
Metals.
Very nice. So metals are electropositive. It means they lose electrons to form cations. Were they right? Then nonmetals are electronegative. What does it mean?
Electronegative, they are gaining electrons.
Very nice. So they gain electrons to do what?
Become stable.
Very nice. So they gain electrons to become stable, and in becoming stable, they form ions. What type of ions do they form?
Anions.
Okay, very nice. So you've defined what an anion is. Similar to how we have three different types of cation ions. We also have three different types of anions. The same concept. So one, we've got monovalent what?
Anions.
What's the other one?
Divalent anions.
Very nice. Divalent anions. The last one?
Trivalent anions.
Very nice. What are monovalent anions?
Monovalent anions are ions that these are ions that
Are formed?
gain one electron to become stable.
Very nice. So these are ions that are formed when nonmetals gain a single electron. Are we fine?
Mm-hmm.
So these are uh, anions formed when nonmetals gain a single electron. Are we fine?
Electron. Yes.
Okay, very nice. And what type of elements on the periodic table will result in the formation of monovalent ions? It means nonmetals which have a valency of 1. Remember, we said from groups 5 up to group what, say, 7, they gain electrons